Okay, here we have a heat pump, and it's supplying energy to a warm space at a rate of 21,100 kilojoules per hour. Okay, and that space is at 21 degrees C, so that's really the hot reservoir that we're looking at. Okay, and what we're trying to find here is essentially, knowing that electricity costs 8 cents per kilowatt hour, figure out the work of the cycle, how much it's going to cost per day to run it, whether I'm pulling this from either the outdoor air or well water at either -5 degrees Celsius or 8 degrees Celsius. Okay, so what I know is that the maximum coefficient performance of a heat pump is relative to just the temperatures, which is TH minus TC, like so, and the coefficient performance is also QH over the work of the cycle. So I know my temperatures, right? T hot is 21. I've got these two different T colds. QH is 21,000. I'm looking for the work of the cycle. Once I have the power that the cycle is creating, I can then figure out how much it costs per day. So what I do here is I set these two equal to each other. Equals TH minus TC all over TH. Okay? And basically, again, I'm going to solve this for the work of the cycle, which is going to be QH times TH minus TC all over TH. Okay? So now all I do is I plug in the different values for the temperatures here to figure out the work of the cycle. So we'll start with pulling it from the outdoor air. So the work of the cycle for this guy is going to be 21,100. And what I'm going to do is I'm going to divide that by 3,600 because this is kilojoules per hour. I want kilojoules per second so I can get it in kilowatts. So I'm going to divide that by 3,600. Okay, and then I take TH, which is going to be 21 plus 273, and I'm going to subtract -5 plus 273 and divide that by 21 plus 273. Gives me a kilowatts, the power 0.52 kilowatts. Okay, to convert that into money, essentially I just take that 0.52 kilowatts, take it times 24 hours to figure out how many kilowatt hours I have per day, multiply that times 8 cents, and I learned that this costs $1 per day. And again, that's pulling heat from the outdoor air at -5 degrees Celsius. To do the same thing for well water at 8 degrees Celsius, I just have the work of the cycle. It's going to be exactly the same thing, 21.1 over 3,600 to get that into kilowatts. And then it's going to be 21 plus 273, that's T hot, minus, now this time it's going to be 8 plus 273. So this is going to be a smaller temperature difference here. Okay. And from this I get 0.26 kilowatts. Okay, so because it's pulling it from more, I've got a smaller temperature difference. This temperature difference is smaller here, okay, which means I have less work input for this one, okay, and then I just take that 0.26 times 24 hours times 8 cents, and I get 50 cents per day, okay. So again, just knowing those temperatures, I can figure out the best performance of my heat pump and calculate, the best or the lowest amount of heat that can go into this, or lowest amount of work that can go into this heat pump.